talk about the role of CXCL13 to induce T follicular helper cell development. And we come up with a problem of, what's the right question for this? What does CXCL13 do? We know that if you take a chamber, like a Boyne chamber, put CXCL13 below, this is the chamber, CXCL13, you do get some cells moving across. They have sort of different polarization characteristics. So we're trying to figure out if, like you just presented, CXCL5 is high, I think, but CXCL21 might be low. And, they're not perfect TFHs. So the question is, what kind of control can we do for this? And one possibility that just came up is to use naive T cells. They don't have any, if this is the two-dimensional plot of CXCL5 versus ICOS, if you use naive cells, they don't have originally any TFH, supposedly. But then the question is, do they come through, will CXCL13 induce TFH? The other thing would be to do long-term experiments. Okay, CXCL13 is the first step. If you use a 2D2, BD2 mouse, we have those, DXC2 or 2D2, they also have follicular, they also have germinal cells, high relative numbers of TFH, potentially cells, or they can have naive cells. Take those T cells and put them in, then you can have them come across and specifically stimulate them with an antigen, being, MOG, myelin oligonucleotide receptor antigen, and it'll stimulate T cells and get the next set of events going. Okay, so that's sort of like an in vitro experiment to look at the effects of CXCL13 and subsequent events, which Yanna proposed in CXCL13. And after that pools, it either enriches or it stimulates the cells to upregulate, we're not sure of the order, but BCL6, IL-21, and ICOS all together. And then finally the IL-21 acts on IL-21 receptor. Now let me go to the second model that comes up with this IL-21 receptor model being so critical, it seems like, for the TFH function certainly. And that comes from her data showing, we just showed that IL-21, DXC2 IL-21 receptor knockout mice had very high levels of CXCL13, presumably produced by FTCs. Be good to look at that, confocal picture of that, showing how it is. But this brings up the following sort of ability to carry forth the in vitro model into an in vivo situation, shown here. We looked at already the IL-21 knockout screens. They don't have anything. They don't have any germinal centers or TFHs. We're not sure that. They don't have any germinal centers. But they have high CXCL13. So we get the impression that this being an early germinal center, or a potential germinal center, there's a lot of dendritic cells producing a lot of CXCL13 in the BXD2 IL-21 knockout. But the T cells don't produce IL-21, and therefore germinal centers don't develop. So the possibility is, how can we use this mouse to follow the event of germinal center development and especially TFH development in vivo? And the idea is, this is what things looked like originally, FTC light zone over here and potential T cells next to them, but nothing's happening. And they develop into this, where now you get a big germinal center, they're pushing away the light zone now over here, full of TFHs that have been selected by CXCL13 to come over here, and then they develop into TFHs, and they make the germinal center, and this expanding mass of B cells pushes the T cells away. So one way to do that would be to use, as a follow-up on the in vitro experiment, is to take cells. They could be, I would say, instead of changing models, we could use the same model. Start with a 2D2, BD2 mouse. Either take naive cells, or first, just take all the cells, and just like this experiment, where we're exposing them to CXCL13, put them into this mouse where CXCL13 is high. T cells then should migrate into that area, and make contact. So we should see that early on. And then what happens next? Well, we don't know. Then we can say, at first, nothing is there. Next, the T cells are in the CXCL13 area. Maybe, but this is the question, maybe BCL6 is upregulated first, maybe IL-21 is upregulated first, maybe they're activated. The T cells should get activated because they're we immunize. Don't forget to immunize the mouse first with myelin. So You got molecular T cells. Maybe they upregulate ICOS, and so therefore, maybe the CXCR5 ones are enriched because they're, there should be CXCR5 enrichment here, and the C is next to the CXCL13 dendritic cells. And then you go down to this sequence of events. So you can sort of tease apart the sequence of events of how germinal center developments, and specifically how TFHs have a role. As we've talked about, this doesn't specifically dissect the role of CXCL13 because that's there. That'll be over here. That's the first step. But it will dissect the subsequent steps. So if you're given that CXCL13 pools in CXCR5 T cells, which is something to check, because we'll have the specific T cells, it pools in the CXCR5 positive T cells. Then what happens? Does it upregulate, BCL6 or next at the same time, or are the T cells that come in already have BCL6 even right from the beginning? When does ICOS go up? I think that's an essential step. And when does finally IL-21 expression get superinduced in IL-21 receptor on the B cells? And then the subsequent events of germinal center. And you can do other tricks. You can take these mice, instead of using naive cells, you can use cells that are polarized to become pure IL-17 producing T cells. They'll come in, and unlike those other experiments where they just throw in IL-21, IL-17 T cells, that we're not sure even that they are IL-17. You throw the polarized ones, make sure they're polarized, but then you can watch what they do. There's IL-17. In our case, we think they limit germinal center migration, but maybe they actually are forming the TFH cells, so you can look at different times. And the other thing is you can put in pure IL-21 polarized cells. So I think that's it. What do you think? What do you think is the first step here?
The first step for the experiment.
Yeah. The first critical. Isn't it exciting experiments to do? One thing, we're making use of some very interesting things. Making use of some novel things here, migration. As a mechanism to separate out cells. We got to look at them more carefully, but separate out cells. We're making use of the IL-21 knockout, which has this interesting property. We're making use of our 2D2, DD2, and and also the ability to image BCL6 in T cells using the TSA. But
we're going to transfer the cells into the IL-21 knockout BD2 mice. Then these mice don't have IL-21, and then I'm not sure whether the cells will go further, develop into the full mature TFH funnel. So how about we transfer the cells into the BD2, because BD2 have very high level of CXCL13, IL-21, and IL-17. Those three are important for development procedure of TFH.
you mean which cells into the BD2?
These label.
Oh,
This
these?
label,
Well, the thing is then it's messy. Here's why, because then you'll be transferring into a mouse that has this already ongoing. You already have TFHs, right? You already have these other germinal cells. So we can't dissect out the development of a TFH so easily. Here, I don't know, you have to look, but this takes a blank, we already looked, the IL-21 knockout is a totally blank slate. And so it may not work, but if it does work, we can watch what happens,
Maybe we can at least see that the CD40 cells located in the FDC area. This one, but whether the germinal center will go on to develop or not, we're not sure.
Yeah, that's true. That's right. Maybe that we can see the first steps, and we can say, okay, this mimics this, and we can look at we can use confocal to see the CXCR5 positive, you did that actually, so forth. Then it may be that germinal.
Isolate the CD40 cells and then look at whether
Yeah. Right. So
but
then.
We still have the same question. How do we know whether self transfer into the cell